An additional type of molecule is what is known as an organic molecule. Organic molecules are very specific. They have to contain carbon, and it doesn't include any molecule with carbon. It excludes a few, specifically like carbon dioxide and carbon monoxide. Those are not included, but it contains carbons with other atoms. And the carbon is always the central atom in these molecules. Now, specifically what we're going to look at is only one of the types of organic molecules. They're known as alkanes. Alkanes specifically have carbon atoms bonded with single bonds to hydrogens. All right. And so these are specifically all single bonds, and it's bonded to hydrogens. They can also have some hydrogens replaced by other elements like oxygen, nitrogen, and phosphorus. Those are some of the ones that are most often the ones that are replaced with them. But all the sulfur is also sometimes in there. And so but what we want to do is be able to simply name the basic organic molecules, the alkanes. And the naming method is just a simple two-step process. First, you're going to count the number of carbons and use the matching prefix. Right? Notice the prefixes are listed over here. The prefixes are all the same as the ones that are used for covalently bonded molecules after number 5, starting at number 5 and going down. But the first 4 actually are unique to organic molecules. And so, but you're going to count the number of carbons. Doesn't matter hydrogens or the other or whatever else is there. It's the number of carbons. And so you're going to use that prefix. And then you're simply going to, the second step is you're going to add the suffix ane, just like they're named alkanes, ane at the end, and we're going to use that same ane here at the end. And so the name is actually shortened because organic molecules are the molecules that make up most of the molecules that make up living organisms, and so they're very common. So we try to use a name that's shorter, so it's not 2 names, it's just 1 name. And so you see that here. All right, we have, so let's do a few of them here. We have CH4. So in order to name it, we're going to count the number of carbons, which is 1 carbon. So we're going to use that prefix, meth, and then we're going to add the ane to the end because, right, methane. Now, how do we know it's all single bonds? I guess that was a good question here. Well, we would actually draw that structural formula, and that structural formula would have carbon in the middle, and you have 4 H's. Well, we're going to simply draw our 4 H's around it. So we see those 4 H's. All of these are single bonds. And so that is methane. Now, if we have C2H6, let's go to that. Now again, C2, first we got to make sure they're all single bonds. So we have 2 C's, then we have 6 H's. So that's going to put a H, 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 H. So in order to get 6 H's, that means all of these have to be single bonds. Hydrogens always have a single bond. That's all they can form are single bonds. And then between the carbon, well, carbon can only form 4 bonds because it has 4 valence electrons. And so this can only be a single bond there. So you know that that's a single bond. That one would be called, because it's 2 carbons, that would be called ethane. Yep. Okay, simple enough. All right, catching on there. Okay, let's slide up and let's look at as they get a little larger here. So C3H8, well, we're going to put our 3 carbons. We know we need 8 hydrogens, so we're going to 1, 2, 3, 4, 5, 6, 7, 8. Oh, nice. So you see they're all the way around. So again, that means hydrogens can only form single bonds. And these carbons, this one already has 3, so it can only form 1 more, which just makes that a single bond. This one now has 3, so that means it can only form that one. And obviously that one now has 4 also. So they all have 4 bonds, which is all they can form. So they're all single bonds, which fits the alkane naming. So this is 1, 2, 3 carbons. So now we're going to use prop. And if you're familiar with any outdoor cooking, you use propane gas, or even indoor heating sometimes uses propane gas if you have a large tank outside. All right. And so these are the 3 of them. I'm going to let you do the rest of them, but let me show you a couple of shortcuts, because one of the things about when you get into organic chemistry, and organic chemistry is offered as an additional study into chemistry, what you would call chemistry 2 here. It's also a medical chemistry that's required if you're going to want to go to medical school. And then organic chemistry is required in college, which is always one of the more difficult classes in a university. So you want to get some experience in high school in this. So a good chance to take this organic chemistry in high school here. And so, but what you see here, one of the things about organic chemistry is because the molecules start getting so big, there's a lot of shortcuts taken. One of the shortcuts is, in this case, we have C4. All right, and we have H10. So that's, and if we just look without even writing the H's, we see that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's going to be all of them. So we know these are single bonds. All right, and what one of the shortcuts is, instead of writing all these H's around, organic chemistry, we simply show the single bond off the carbon, and because there's nothing written there, then it is assumed that is a hydrogen. And so you don't have to write the H's in. All right, I'll let you name this one from that. Another shortcut is as you get larger molecules, we will use simply lines and in a zigzag pattern to show a carbon chain. This is called a carbon chain or a carbon backbone. And so when you have a bunch of carbons in a row, and so what they do is use a zigzag line. So we need 5 carbons. So we'll use a zigzag line, and every end of the line or corner represents a carbon. And so that would be a carbon here, a carbon there, carbon there, carbon there, there, and there. So we've got 1, 2, 3, 4, 5 carbons right there. And so that'd be a carbon backbone. And then again, to do our H's, we will put them there. All right, and that's another little shortcut that you'll see, especially in biology. In biology classes, you'll see this used in your organic molecules. All right, now, so the formula for alkanes, and so I'll let you name the rest of those. And so the formulas that we use are for alkanes. The formula is always carbon has a certain number, and the H is always 2 times that number plus 2 more. And so, for example, for bute, we look over, find the prefix for bute. Bute is a 4. So we have C4, and then we have H's. We're going to have 2 times that 4, the N, which is 4 here. So 2 times it plus 2. So we have 2 times 4, which is 8, plus 2 is 10. Okay? Hex would be C6 times 2 is 12, plus 2 is 14. Okay? Let you finish those out. I think you can do this really well. Post any questions you have down in the comments below, and I'll be sure to get back to you. Good luck, guys.